Hello everyone and welcome back to another episode on complete reference to CUDA programming. This is going to be one of the important episode in the entire playlist where we'll try to understand typical execution model of a CUDA program which is applicable to all CUDA programs. To understand that, first let's try to understand what are the steps that we follow when we write a typical C program. So first we include some libraries like stdio.h or stdlib.h or math.h to use some mathematics functionalities. So for that we first include some libraries. Then we declare some variables and allocate memory to the variables to store the data. Now once memory allocation is over, we initialize those variables by either in the program itself we can initialize the data or sometimes we can fetch the data from the hard disk. Now once data reading or initialization is over, then we are going to perform some operations on the data. And for that we can launch multiple functions to perform those computations. And once computations are over, we are going to store the results into another variables. And finally, we are going to free the memory from the CPU's main memory. So if you allocate memory using malloc functions of C, then using free function, we are going to free that memory from the RAM. So these are the steps which we follow typically when we write any C program. Now let's try to recall what we said about GPU. We said that in earlier episodes, GPU is nothing but a coprocessor or an accelerator. That means which takes only the computational intensive task, and remaining tasks, those are not much computational intensive, that is only executed on the CPU side. So if you recall this again, the same diagram again I am referring here also that we discussed in the earlier episodes. So here when we start executing any CUDA program, so initially control is towards the CPU because we are only transferring the computational intensive part of your program to the GPU. The rest of the instructions from your program still will be executed on the CPU side. So initially when you start executing program, a process gets created and control is towards your CPU. Now CPU is having its own memory and GPU is having its own memory. Now whenever we reach to the point where the compute is to be very intensive and we need to transfer that computation to the GPU side, then the control is given to the GPU, and at this particular time GPU start executing in parallel all these instructions that are given by the CPU. Now while GPU is executing all these instructions, CPU is sitting, CPU is not having any control. Now once computations are over in parallel, the results will be given back to the CPU side again, and now again control is toward the CPU. So this is how a typical working of CPU and GPU while executing a CUDA program. So let's try to understand in detail now how this process gets executed. So as I mentioned earlier, CPU is having its own memory and GPU is having its own memory. So first what we do, we declare variables on CPU side. So here the number indicates the step number here, that is depicted here as well. So first step is we are going to declare variables on CPU side, just like your C program. Then we allocate memory for those variables in the CPU's memory. So you can see here in second step, we are allocating memory to the CPU side. Now we are going to declare some variables for the GPU memory and we are going to allocate memory on the GPU side as well. The reason why we are doing this is, ideally what we expect is, if let's say I want to perform any computation on CPU, so obviously CPU is having access to its own memory, so data must resides in the CPU's main memory. But now if let's say some computations I have to perform on the GPU side, then obviously the data corresponding to that computation must reside in the GPU's memory. So for that reason, we have to declare some variables on GPU side and we have to allocate memory on GPU side to hold that data required for the computation. And for that reason, we are declaring variables on GPU side and also we are allocating memory to the GPU variables on the GPU side. So this is the step number 4. Now we are having variable CPU side as well as GPU side and memory allocated on the CPU side as well as GPU side. Now we have to perform the computation, but for that computation first we need to allocate or we need to initialize or read the data. Now next step is we are going to initialize data in the CPU main memory. So whatever variables we have created, we will take input data from either from hard disk or we can initialize the data in the program itself, and that is residing on the CPU's main memory. Now if I want to perform this some computations on that initialized data on the GPU side, so obviously first data must be copied from CPU's main memory to GPU main memory, because whatever initialized data is there, that is currently present on CPU's memory, but I have to perform operation on the data in the GPU. So obviously the data first need to be transferred from CPU's main memory to GPU's memory, and that is our step number 6. Now once that data is available on GPU's side, then CPU can instruct GPU to execute in parallel or to perform computations in parallel on that data. So that is our step number 7, and that is what we call it as a kernel execution, or we can say a function that to be executed on GPU. In previous video, we have seen what is a GPU function. So while launching that GPU function, we can mention all these instructions, how to execute in parallel and which thread to be executed on which particular data. That is all mentioned in this step number 7 here. Now after a parallel execution on the GPU side, now we are getting those results, and those results are still available in the GPU memory. Now we have to copy back those results from GPU memory to CPU memory, because once we execute in parallel, we got the results. Again, we have to get those results from GPU memory to CPU memory, and that is our step number 8. And finally, once we get the data, now we are done with our computations. So simply we can free the memory allocated on CPU side as well as on GPU side. So these are the 9 steps that we typically follow in any CUDA program that we are going to write in the future. And this is very important to understand how typical CUDA program execution works.